Up to this point, all our models have done is what's called controlling for age. And so remember, what that means is that if we were to think about, okay, here is the line, right, we have age, we have birth weight. Here's the line for smokers, and here's a line for non-smokers. What that's saying when we control for age is when we're saying, okay, there's a difference between these two lines, and it doesn't matter where on age we are, that difference is going to be the same. Okay, so what that means is we're adding together the effects of smoking and the effects of age, or the relationship between smoking and birth weight, and we add to that the relationship between age and birth weight. And this holding constant is very powerful. It's a wonderful thing, but it's often not a good model for the phenomena we're interested in studying, and we want to be able to expand things in a slightly different way. And modeling statistical interactions is an alternative. Okay? And what statistical interactions do is they allow relationships to be either bigger or smaller as values of the variable change, right? So that what we would see is instead of parallel lines like this, we're going to see, it could be anything. It could be something like that. So here, the difference is much smaller than here. And that's what an interaction looks like. So often by just simply graphing kinds of relationships, you can see whether there is a realistic interaction between two variables by just seeing if the lines are parallel like this, or do they have a non-parallel form. Okay? And what this interaction is it allows us to examine multiplicative relationships. So we're not just going to add things together this way. We're going to actually do some multiplication. That's going to allow for these kinds of things here. Okay? So our definition of an interaction, this is really important, so make sure that you listen to this portion, read the portion in the textbook, and then ask any questions you have about this, because this ends up being pretty critical. Okay, interaction. The size of a relationship between a predictor and the outcome depends upon the specific values of another predictor. Okay, so we could say that to put this in the words of the example, the difference in birth weight between mothers who smoked and mothers who didn't depends upon the specific age of the mother, right? So again, if this is age, this is birth weight, and we're drawing this relationship again, okay, the size of that difference, right, is related to the specific age, right? So that's that specific value, okay? So the difference in birth weight between mothers who smoked and mothers who didn't depends upon the specific age of the mother. Okay, or you could say the difference between treatment and control in a randomized controlled trial. Treatment control depends upon the level of the pretreatment symptoms. Okay, so what I want you to do is just think. Okay, we've talked about partial slopes. That's when we're controlling for age. Okay, what's the difference between this partial slope and an interaction? So I want you to pause it and I want you to think through that and try to articulate that. Okay, so what does it mean? Okay, so when you're dealing with a partial slope, you're just controlling for the presence of another variable. So we're saying age has an important relationship with birth weight, smoking has an important relationship with birth weight, and we're going to control for whether they smoked or not. We're going to control whether it's there or not, right, in our model. That's what a partial slope does. So it's just the presence of a variable. Interactions, though, say that those variables, it's not important or good enough to just have that other variable in the model, but that we think that the variables literally influence one another. These predictor variables literally influence one another to create a different relationship with birth weight. Okay, so interactions are quite different. My graduate mentor, major professor, used to say all interesting scientific debates are essentially interaction questions. And so I think they end up being really important. Okay. All right, to add interaction to the model, what it involves is adding an additional term to the end of the model. So I've written out our interaction model here. You can see it here. up to, this first part up to this last plus sign, and we've seen before. We've got smoking status and we have age. And now we're going to add this third thing, which is the product of smoke and age. So we just multiply those two things together. So in Stata, you could just generate a new variable that's literally, generate age times, or smoke times z age, and that will produce what you need. Or you can do it on the fly with factor notation. And so generally, I would just encourage you to do it with factor notation. Let Stata do it for you. So here is our model again, here up at the top, and I've got the regress command that reflects this model. So we've got factor notation. Okay, so I.smoke. The C.zAge just is to signal to Stata that we want to treat that as a continuous variable. You actually don't need to do that for this one, but for this zAge. And then I.smoke with the pound sign, C.zAge gives you the interaction term at the end. You do want to use the C.zAge here. And again, if not, it'll try and treat it as basically it'll try to dummy code age, which is a real problem with all the values of age that we've got. And that's not how we want to represent age anyway. We want to represent it as a continuous value. And you can see that you get your results here down at the bottom. And you get a coefficient for, this would be B1, this is B2, and this is B3, and our intercept again. And we've got a bit of work to do before we can directly interpret these, so we'll get working on that now. Okay, so a couple of additional terminology things as we delve into the interpretation at this point. Okay, the B3, this smoke by zAge, is our interaction effect or interaction term. Okay, these guys here, B1 and B2, they are your first order effects. You'll sometimes hear these called main effects. And I know why people use that term. I think the term main effects can be confusing because it comes out of the ANOVA language, and main effects in ANOVA mean something different than first order effects in regression. So I'm going to call them first order effects and expect you to do the same. Okay, so this is our first order effect for B1, our first order effect for B2, and then our interaction term. So what we're going to do is we're going to, just like we did with dummy coding, we're going to walk through expected values to help us understand what each of these terms mean. All right, so the first one we're going to look at is we're going to take this full model and we're going to say, what's the expected birth weight for babies whose mothers did not smoke? Okay, so if mothers didn't smoke, then this value is 0. We aren't saying a specific age, so that's just going to stay zAge. And then if we come down here, smoke is 0 and zAge stays in there. Okay, so if we write this out down here, so we have B1 times 0, B2 times zAge, B3 times zAge times 0. Okay, so we're going to get rid of that because that zeroes out. We're going to get rid of that. And what's left over is this smaller regression equation. So what this says is this is the expected birth weight for babies whose mothers did not smoke. And so you have an intercept and a slope. Okay, so let's think through what these terms mean. So B0 or B0 is the expected birth weight for babies whose mothers did not smoke and whose mothers, I don't know why I'm putting an apostrophe there, whose mothers were at the average age. And why is it average? Because we've z-scored age, and the mean is at 0, right? So it's the expected birth weight for babies whose mothers did not smoke and whose mothers were at the average age. Okay, so let's think about what B2 means. So this is the relationship, right, between increases in age, or 1 unit increase or 1 unit difference in age, and birth weight, but it's for a specific group, for mothers who did not smoke. Okay, so expected birth weight, or B2 is the expected difference. Expected difference in birth weight for a 1 unit difference in age, or Z age, which is 1 standard deviation, right? A unit difference in Z age for mothers who did not smoke. Okay? So what you can gather from that is B2 is a very specific interpretation. It goes with a specific group. And remember our general interpretation of an interaction. It is that the relationship between one variable and another depends upon the specific levels of a third variable. So the relationship between age and birth weight depends upon the specific value of the smoking variable, right? And this is going to describe the specific value for mothers who did not smoke. Okay, let's continue on. So let's now say what's the expected birth weight for mothers who did smoke. Right? So now we put in a 1 for age, or for smoke. Age we aren't conditioning on. We don't have a specific value for that, so we leave that there. And then we do Z age times 1, because the smoking variable gets there, and you just go through and do this. You simplify and you get B0, B1, B2 times Z age, and B3 times Z age. Okay? So what I'm now doing in this last line right here is I'm just going to group the terms. So I'm going to group B0 and B1 together, because they aren't multiplied by anything. So they're going to be essentially intercepts or constants. And then I have B2 and B3, which I've factored out, right? I've factored out Z age. So we have B2 plus B3 times Z age. Okay? So this should look like a regression equation, right? This is this term together is our intercept. These terms together are our slope for age. Okay? So the expected intercept for babies whose mother smoked is B0 plus B1, right? So this is the sum of those two is the expected birth weight for babies whose mother smoked and whose mother is at the average age. Okay? These two things together right here, right, are the slope for mothers who smoked. Okay? So this is going to be the expected difference in birth weight for a 1 unit difference in age for mothers who smoked. And for babies whose mother smoked, right? So the sum of those two things are that. So the sum of these two slopes, okay, give you that expected difference. Okay, so let's go ahead and interpret B1 here. Okay, that's going to be our main focus here. Okay, the interpretation, and I'll explain why, is this is the difference in birth weight between mothers who smoke and no smoked, right, who didn't, at z age equals 0, right? So it's the difference between mothers who smoked and didn't smoke when the mothers are at the average age. That's this one. Okay, so notice that it's, if we didn't have the interaction in there, right? If that wasn't there, then we would say this is the difference between mothers who smoked and didn't smoke holding constant age. Well, because we have interactions in the model, we're no longer holding constant age. What we're saying is that this is the difference between smoking and non-smoking for a specific age, and that's, in this case, it's the 0 value. Okay, so let's walk through why that's the case. So we have the expected value of birth weight for mothers who smoke and who are at the average age. So we walk through that. Okay, so we multiply, this is the mothers who smoke, so we multiply B1 by 1. We multiply B2 by 0 because Z age is 0. And then we plug in 0 for Z age and 1 for smoke here. Okay, and then we just simplify, so we're going to get rid of those two terms. So our expected value for mothers who smoke or at 0 age is this sum, right? It's the intercept plus B1. Okay, so now let's just do the opposite, right? Or the difference. So we have remember my interpretation up here is the difference in birth weight between mothers who smoked and no smoke. So now we're going to do the no smoke version. Okay, so we do no smoke. So now we're going to put in 0 for smoke, 0 for smoke, 0 for age, and then 0 for both of them. So now we can just simplify by getting rid of all three of these, and we're left with the intercept. So if we want the difference between mothers who smoked and mothers who didn't when age is 0, then we just take the difference between those two. Okay, mothers who smoked and mothers who didn't, we take the difference between them, right? So here's our B0 plus B1 right here. Then we subtract out B0, and it's left with, down here, right, we just get rid of this, and we get rid of this other one. Right here. And we're left with B1. So that is why that interpretation is that, right? It's the difference between mothers who smoked and did not smoke when age is 0. So now let's extend that logic here, okay, for B3. So if B2, just in this overall model, is the relationship between age and birth weight for mothers who didn't smoke, B2 plus B3 is, as we saw, is the relationship between age and birth weight for mothers who did smoke. So if we wanted the difference between the slope for the mothers who smoked and the slope for mothers who didn't so if we say smoke minus no smoke, and we're talking about the slopes, it's going to be B2 plus B3, which is one for that, minus B2. You reduce that, and you get B3. So B3 represents the difference in the age slope or Z age slope, I should say. The difference in the standard or Z age slope for smoking mom versus no smoking mom. Okay? So if we're to think about it this way, we've got the smoking mom slope, no smoking. So this is no, this is yes, this is birth weight, this is age. Okay? This slope differs from this slope. This slope right here is B2 plus B3. This slope down here is B2. B2. Okay? And the difference between the slopes, so the difference between the slopes is just B3. It's just that one. So B3 is the delta, or the difference between the two. And we can walk through the numeric examples, and I do so in the textbook as well. But the key thing for you to do right now is just to remember that as soon as interactions come into the model, these terms take on very specific meanings. And if I had to identify the most common misinterpretation of regression coefficients that I see in the literature, I see in consulting I do, or when I make a mistake, or when I'm on a thesis committee, that sort of thing, it's that people forget that regression slopes change as soon as you have interactions in the model. Okay, last thing for this video. Now, imagine we've got our full model here, but then we add mother's last weight here at the end. So we've got these interaction, we got the two first order coefficients, we have the interaction, and now we have this thing down here, okay, which is our coefficient for mother's last weight. Okay, how do we interpret this B4? Okay, what this is it's the one for every 1 unit difference in mother's last weight, we expect a B4 difference in birth weight holding constant age and smoking status. Okay? Forgive that extra bad writing on status there. Okay? All right. So the key thing I'm wanting to tell you is that when we're talking about that adding an interaction in the model changes the interpretation of the coefficients, that really only matters for coefficients that have variables that have an interaction. So the fact that there's a smoke by age interaction affects these two things. It does not affect this third one, except that we're holding it constant, or holding the other things constant. Okay, so this is just ends up being a plain old covariate, and this is a partial slope. The fact that these are first order coefficients only happens because we have smoke and age in the model.